Oh yeah, there it is. Welcome, Peter DeMeo. How are you?
Good. How are you doing, Adam?
I'm doing really well. We're doing the real full other side of the world recording here. You're in Singapore, and I am in Florida, East Coast of the United States.
That's right.
How is it over there?
It's very, very warm.
Same here in Florida. Well, hey, thanks for joining. Hey, everybody out there at in BINARYSTAR land and my name is Adam Mastrelli. I'm the North American Digital Assets Lead for IBM. And with me, as always, our leader in chief here, Peter DeMeo, is our global lead for digital assets and the HyperProtect digital assets platform, which we will get into at IBM. So he's got an incredible track record. He's been doing this for a really long time, tons of great experience. And we're going to dive in with a little 20 questions slash working through, what our platform is, can public and private companies work with us? Why IBM? What does it actually do? Is it the blockchain platform? Is it consultancy? We'll answer all those things in 20 minutes, Peter. It's going to be amazing.
Or less.
or less. So just a little bit of context to the folks out there watching this. So when you think of IBM, right, obviously you think of larger clients, right? You don't think of crypto. You maybe think of blockchain platform. I see Peter nodding his head because we hear this all the time. You think of Hyperledger, IBM blockchain platform, TradeLens, Walmart. Those are all great. And our company does a fantastic job working with those networks, right? What Peter and I do is a base level zero below that. And we'll get into talking about what that means, but we'll underpin that. What we're talking about today is not that. It is not Hyperledger. It is not the IBM blockchain platform. It's a very specific piece of infrastructure. You can think of it as a platform, actually, to run all of your digital assets in, and we'll get to that. And it's called the HyperProtect Digital Assets Platform. So I just wanted to make that very clear. We're seeing, who do we see interest from, right? We see interest from staking platforms, crypto exchanges, tokenization platforms, custody providers, banks, and other parts of the crypto ecosystem. Just a small, and Peter's nodding his head because he's been doing this for a few years. This really came out of our legacy infrastructure business. So, whether you know this or not, just a few basic statistics, 85% of the world's credit card transactions run on IBM systems, right? 92 of the top 100 banks in the world run on IBM systems. Right? When we talk about downtime and security and reliability for things that really matter for transactions, we're measuring this on our systems in decades for as far as downtime and reliability. So transactions, cryptography is not new to IBM. And transactions, cryptography, and protecting those transactions is not new to IBM. So from that legacy business came what Peter really saw in the market and, kind of started essentially with this world. So Peter, that's kind of accurate, right? That's what happened there?
Yeah, absolutely.
Good. So before we get into specifically what the platform is and where you and your companies and how you can shout it from the rooftops and debunk a few myths of what IBM is and is not, just a little list of a snapshot of our client base, right? And these are going to be customers and clients that you know and love, both in Asia Pacific, all from Asia Pacific to Europe and to North America. So Hex Trust out of Hong Kong, custodian, On-Chain out of Singapore, Swiss Chain, Phoenix Systems, Core, Mataco out of Switzerland, Main Block out of North America, Custody Digital Group, I believe also in Switzerland, and maybe, I could be wrong, Europe, and DAX. So this is just a snapshot of people that are using our platform that are in the crypto space every day, dealing with digital assets, bearer instruments, right? So we do more than that, but that's what we're doing. You'd be very shocked. This is not your father's or grandfather's IBM, as they say. This is a really, really exciting part of our business, and Peter is at the helm. So Peter, I know you and I do this all the time. Let's do the dog and pony. So maybe you can jump into a couple of slides and walk us through, what we're really solving here and why IBM.
Okay, that sounds good.
Yeah.
Good idea. I'll just
Thank
do
you.
that.
It's like we haven't rehearsed this.
We actually haven't. Okay, thanks again, Alan. I really appreciate it, the intro. What does IBM do for you, right? And what are the things that you need to be done? One is that you want liquidity, and you don't want to lose it, so you want high security. And if you're doing any work that ultimately will be in a regulated industry or with a regulated institution, you care about compliance. And so it's really a bit of a trade-off. You know, when you think about liquidity, you generally think of a hot wallet, but then hot wallets aren't very secure. Or if you're, really want security, you're thinking about cold storage. It's offline, but not very liquid. And then, compliance. Well, quite frankly, very few people even think about compliance, right? What we have with our technologies and what we do for this market fundamentally is that we say we can do all three at the same time. And that's because we look at this market completely differently than anyone else does. So how do we do that? Let's talk about a little bit what sits behind it. Mm-hmm. So we have what we call magical assets, and there are three of them. Now, the first is we have what's called a trusted computing base. And this is nothing more than a whole set of hardware and firmware and software infrastructure, if you will, where you can take your applications and your databases and you just run them. And we take care of everything else. You don't need to worry about encryption. You don't need to worry about insiders. You don't need to worry about, external parties being able to snoop around, cloud administrators and what have you. None of that's possible in the trusted computing base. Now, the second thing is what we call secure image build. If we have a trusted computing base, that's a great place to launch attacks because it's, trusted, it's, confidential computing. So we need to make sure that applications deployed into that environment don't have any malware in them or backdoors, right? And, when you think about your DevOps process, it's generally, a set of privileged, engineers who really understand it. And what if they have malicious intent and they deploy a different kind of application? How would you even know? Well, with secure image build, you do know because it's fully attested deployment. And then finally, though we won't really get into this, but we have a whole different way of looking at storage. We do not believe in pure play cold storage equals security. Okay, what we think about it is digital assets need to be controlled. They need to be controlled in terms of who accesses those and who uses them and under what conditions for signing transactions. And so what we have essentially is the ability to encrypt assets and externalize those encrypted assets and put them into something called a cloud object store, which serves as a repository where the assets are not accessible, okay? And even if they were, they are encrypted, okay? But they could be used for a transaction if a certain policy and permissions and authorizations allow for it. So you could pull it in and use it for that transaction without ever having to have any humans involved or really have any concept of walking something from cold storage to hot, right? We don't even have the concept, if you will, of hot, warm, and cold. It's just permission, use, and control of digital assets. And our technology is expressly designed to provide that. And we think that's really a bit of a game changer because, digital assets running on our IBM HyperTech Cloud are safer than anything you have in your data center. Hard stop.
Yeah. And again, Peter, you and I talk about this all the time. It can either be done on premise or in the cloud.
Yeah. And we'll get to that too.
Okay.
So before we kind of get into how those claims work, let's talk just briefly about how is it possible that you would have to worry about a system takeover. And I think the Twitter example is probably a good one from before, right? You had essentially a compromised employee, and through that compromised employee, external parties were able to manipulate, the Twitter tools, and then obviously create the the confusion that they did, right? So if you think about it, often the case, and this is a bit technical, you have someone like a system administrator who has access to these applications. And in this case, there's a special type of technology for containerized environments called Docker. And if that system administrator is a member of the group of those who are using Docker to do application deployment, okay, then, you know, there's a chance that if that individual has been compromised, that person who did the compromising could actually get access to those tools. Okay, so we have in this case, I will be the system administrator because I have brown hair, and we have with a little bit darker hair, Mr. Evil Administrator himself, Adam Astrali, Evil Adam. Now, Evil Adam and I work together, and you know, I like Adam, right? So when Adam sends me an email, of course I'm going to open it, right? But of course he's evil, so that email, in fact, was a phishing attack, and he now has control over my credentials, and he has the ability, okay, to do anything he wants, but I don't even know about it. All right, so that's where things are. So the next thing, he's like, all right, I need to get to the Twitter tools, for example. So how do I do that? Well, he can now do what's called a Docker permission escalation exploit, and all he has to do is run this command, and then essentially I am transformed into Evil Adam, or Evil Adam is transformed into me. It doesn't really matter, because once Evil Adam has access to that Docker group, he's now able to go after the Twitter tools. And so this is basically how you would become, if you will, a compromised employee, okay, as an example. Now, let's say that Evil Adam is responsible for setting up wallets. Let's say Charlie has a BTC wallet, and just for kicks, he's doing that on AWS. All right, now AWS and Azure and Google, Alibaba and others that all use what's called x86 or Intel-based infrastructure all have the exact same level of assurance, which is called operational assurance. And operational assurance simply means this: though we have access to the infrastructure, we have access to memory, we have access to the operating system, we have access to your keys in a cloud HSM, we promise, because we're very good people, we promise that we're not going to take your key material, and we're not going to go snooping around in the systems that are running on our infrastructure. We promise. Because we own it, but we promise. Now, you know, anyone who's running on AWS, you're renting. You have no idea, right, who's doing what. And you just kind of hope that they don't do anything bad, right? But you are talking about a lot of money, aren't you? So what could happen if you only have operational assurance? Well, let's say Evil Adam shows up, and Evil Adam is setting up Charlie's BTC wallet. But because Evil Adam, well, he is an admin, he has access, he can create what's called a terminal session, right? And then dump the memory from Charlie's wallet into a file, okay? And then he can read the file to obtain the seed material for Charlie's wallet. And then he can create, well, Devil's wallet, why not? Now, Devil's wallet, BTC wallet, points to the same place on the blockchain, of course, as Charlie's wallet, right? So then if Evil Adam decides to drain Charlie's wallet, all he has to do is transfer the funds from Devil to his good buddy, Eddie. And then Evil Adam can go have some beers with Eddie, right? Because they have money. Charlie, he's left holding the bag. He's got nothing, okay?
Sorry, Charlie.
Now, all of this is because of operational assurance, that level of assurance. What you want, in my mind, is technical assurance. Now, technical assurance says technology prevents you, even though you're Evil Adam, but technology prevents you from being successful. Technology enforces you to behave yourself. Okay? And that's the difference between IBM HyperProtect and everybody else, because we are the only ones who can provide technical assurance. Hard stop.
Yeah, Peter, I love this. So when, you know, we've had these conversations, insert 3-letter organization, you know, law enforcement organization that comes to you and says, hi, IBM, I need Peter Co. and Adam Co.'s information. They're running on HyperProtect Digital Assets platform. I heard I need to take a look. IBM can literally say, we can't see it. We literally don't have access to it. And I think in today's day and age, infrastructure matters big time in that case. You'd agree? This message seems to be resonating with our clients.
Yeah, absolutely. A lot of our clients want to be able to say to their clients, because our clients are those who provide technology to them for digital asset solutions, that there is under no circumstances can we obtain your assets. It's this idea of control versus possession. We always have control and can provide control to the end client, okay? But possession could be with the custodian or the exchange or whomever. But that control could always be taken away. Right? And if there's ever a problem, you can freeze assets instantly and never lose anything for that matter.
Right. And what does technical assurance look like in our cloud? I think we have another graphic coming up.
Yeah, so technical assurance is really manifested in this idea of enclave technology. So here we have the HyperProtect virtual servers, and we have Alice's wallet with her BTC, and Evil Atom cannot access her wallet because there's no way in, if you will, as a backdoor. Okay, you only have well-known what they call REST API communications. So there's no command line, so you can't type anything. There's no secure shell. There's no access to memory. There's no access to the operating system. It's very much locked down, and the size of these enclaves is quite large, up to 16 terabytes, as opposed to some competing technologies which are a lot smaller.
Peter, do you have the image of what the platform looks like? The larger image somewhere.
Yeah, we'll show you that in a little bit.
Cool.
Okay. Now, if Evil Atom wanted to get to Alice's wallet, he realizes that he cannot get to her wallet, directly. Then maybe he'll take an indirect approach, and he'll do, because he's the administrator of her wallet as well, right? He might go to the console and say, hey, I want to dump Alice's wallet. And well, he can do that because that's a legitimate permitted activity, right? It's not like it's an activity that he's doing illegally or without authorization. But here's the thing, even if he was to do that, the data are encrypted, okay? And there's no what you call user data. So Alice's content's not in there either. It's just system data, and that's encrypted. And Evil Atom does not have access to decrypt it. So whether the information is being stored in the virtual enclave, whether it is on the network, whether it is stored somewhere in a persistent manner, or whether it's being pulled as an encryption volume dump, it's all encrypted. All right, and that's where the difference is, because the technical assurance is that encryption. It is pervasively provided. There is no way around it. It is just there. And IBM technology does it all for you. And that's what makes it really interesting for a lot of digital assets clients, because encryption is part and parcel to being able to have safe operations. Well, if you're running on an operationally assured cloud, you really don't have that assurance, do you? It's only when you're running it where you have full-on enclave technology as well as hardware security module technology and pervasive encryption around everything, where administrators, your administrators, our administrators don't have access. It's just done for them. And that's really, what sits behind, what we have with respect to our technologies.
Yeah.
Now, this is the trusted computing based part. Let's look at, how do you put stuff in there? Well, what we do is we have something called secure image build. And this is that second magical asset. And how does that work? Well, basically, if you have an application to deploy, you can sign it and that signed image was what was deployed, right? But how do you know what was in the signed image? It's not exactly self-evident because, well, you can't read binary code. So what we like to do is to create the image in one of these enclaves. And in doing so, we also sign it and push it out to a trusted repository. And then we produce something called a manifest. And a manifest is really important because that actually is what was in the build. And so if I have the build is locked down because it's encrypted, and I have a manifest which has exactly what that encrypted build was, and that's also locked down, okay, I can then introduce a third party to an attestation on the build itself. And that's technical assurance for the deployed image. And this is how you can make sure that what you think is being deployed is what is being deployed, and you can prove it. So if you have a regulator, compliance officer, security officer, what have you, you can demonstrate that this in fact was deployed. And even if you're evil, you still can't get around it. And then once it's been, signed off by, let's say, the auditors, it will then be pushed into a production version of these enclaves. And the claims here that you really cannot alter the build environment, the code, and things of that nature. So it's legit code. And what we do with this technology is not only do we deploy wallets and databases and applications, but we also deploy smart contracts and even business processes that we transform from a set of activities that you can see into a set of activities that are a binary image that's now immutable, and you cannot manipulate that image because it's now running in an enclave using secure image build.
Got it.
Okay.
Got
So
it.
when we think about these applications and these technologies together, we have the ability to kind of limit the attack surfaces, right? So, the first one you might look at, what Evil Adam would go after, is what's called a secure boot. So, as this thing is starting up, right? Can I insert malware? Can I do bad things? And you can if you are working with AWS, or if you are working on x86 machines, or a competing technology from Intel called software card extensions. They all have one thing in common. They're not a secure boot technology. Ours is, okay? And actually at multiple levels. And then if you are trying to, thwart the applications that are running inside of these enclaves, whether those are permission blockchains like, Fabric or Corda or Ethereum, or just digital asset applications, wallets and so forth, it really doesn't matter. The evil administrator just doesn't have access. Hard stop. They cannot do it. Now, the next thing is that if you try to insert malware or backdoors, you're going to stop because of the secure image build that we just talked about. We didn't really get too much into the keys, but suffice to say we have FIPS 140-2 level 4 hardware security module technology, which is the highest commercially available. And if anyone were to try to get your keys, they would be zeroed out in 100 nanoseconds, literally frozen and protected. And we have a special technology through smart cards to allow you to restore that, but only you, not anyone else. And then, if you're trying to intercept communications, network attacks and so forth, it's not possible because all of these communications are done encrypted and in hardware. And then finally, of course, if you're trying to exploit a bug, a vulnerability in an application running in an enclave, we can literally cryptographically shred it. Try doing that on Amazon. And then we can redeploy a fresh build using secure image build. And so all of these together, we close out all the very common attack surfaces. And then to your last point, Adam, it's kind of like a Burger King Whopper. You can have it your way. This technology is available on the IBM cloud. It is available on premises. It is available in what we call mix and match. So you can have some of it running in your data center, some of it on the cloud. We can also integrate with other clouds. We have, for example, clients that do run on AWS as well as use our consume our crypto services. We have clients that have got everything here on premise and basically provide a custody infrastructure as a service. We also have clients that provide just the enclave technology on the cloud. There's many different ways to slice and dice all of it. But one thing is for sure, no matter what, everything running on this platform is more secure than whatever you have today. That much I can say for sure.
Yeah, I love it, Peter. I think that's all for our time. So just a big thank you to you for spending your morning with us here.
Thank you for your time.
My evening. I always love hearing from you. I like the new slides. Some of them I've seen before. But again, for those watching, I think the thing that I really take away from this always is, we've done this at IBM for some of the largest financial institutions in the world. You may be familiar with the financial services cloud that Bank of America and BNP Paribas just launched. So in a lot of ways, what we're doing here is the digital assets version of that. And it's a whole new world, and we're going to be at the forefront of it. So we really look forward to hearing from you. Thanks for having us, and have a great day.
Thank you. Bye-bye.
Bye-bye.